Something very strange has appeared on our horizon. Not a flash of light or a sudden radio burst, but a question that, once asked, refuses to be ignored. How fragile is our planet really? For 4.5 billion years, Earth has been an astonishing survivor. Molten birth, cosmic bombardments, runaway climates, ice ages, and asteroid strikes. Yet here we are, a single blue world teeming with life, perched in a vast and indifferent universe. And now, with human knowledge and technology advancing faster than ever, the old certainties feel both more wondrous and more alarming. Could we, for the first time in the planet's long history, truly obliterate Earth? If so, how? This program is a journey into that uneasy possibility. Not a science fiction fever dream, but a careful, sometimes disquieting exploration of the physical processes and technologies, natural and man-made, that in the right combination could unmake a world. We will not sensationalize. Instead, we will listen to scientists and engineers who study extremes, particle physicists who coax the fundamental building blocks of matter, planetary geologists who read impact scars like forensic evidence, roboticists and nanotechnologists who push the boundaries of self-replication, astronomers who map the graveyard of failed stars. Each expert brings a sober appreciation for both scale and consequence. Their verdict is rare. Some methods of planetary destruction are effectively impossible with foreseeable technology. Others are theoretically plausible, terrifyingly elegant in their efficiency, or simply require time on a scale that renders them irrelevant to us. Our mission is to sort the plausible from the impossible, and along the way to discover what these thought experiments reveal about the planet we love. We begin with a set of images that feel like the end of the world. A tiny, perfect black dot in the center of a spinning disk. A blazing comet hurling through a vacuum. A mountain-sized robot multiplying in a deserted industrial complex. A marble the size of a bead whose gravity rends continents like tissue paper. Each of these images connects to a real branch of science. Black holes and high-energy physics, long-period comets and orbital dynamics, self-replicating machines born from robotics and molecular engineering, antimatter annihilations that convert mass to pure energy. Each is a strand in a braided tale of cosmic and terrestrial risk. But this is not just a catalog of ways to end things. It is a story about scale and the counterintuitive ways physics hides power in the smallest and the largest places. A microscopic particle collision in a collider can teach us about the first fraction of a second after the Big Bang. A pebble's impact on a primordial Earth can change the course of evolution for 100 million years. A sliver of antimatter annihilating with ordinary matter converts matter into stupendous amounts of energy. But collecting that antimatter is a Herculean task. Timing matters. Distance matters. A device's capability does not translate directly to planetary consequence unless mass, energy, or gravity conspire in the right configuration. This introduction is also a human story. The questions we ask about destroying a planet reveal what we value about saving one. Scientists who study extinction processes are often drawn by curiosity, not malice. Engineers who imagine moving planets do so to understand and perhaps to someday protect them. The same knowledge that allows us to model the effects of a large impact also fuels planetary defense strategies. Our examination will therefore be balanced. For every destructive capability we consider, we will also look at its inverse, how similar knowledge could be harnessed to shield life, nudge an orbit, deflect a hazard, or rebuild after catastrophe. Finally, the central question that will guide us through the coming parts is carefully framed. What would it actually take in terms of mass, energy, time, and technology to render Earth uninhabitable, to tear it apart, or to erase it entirely from the solar system? We will not stop at evocative metaphors. We will follow the numbers to their logical conclusions, keeping always in mind the difference between could theoretically and can realistically. Along the way, we will confront ethical reflections. What does it mean to possess the power to end an entire biosphere? And how should a civilization steward such capability? So listen closely. Over the next episodes, we will trace 6 leading scenarios, from gravitational annihilation to engineered catastrophe, and interrogate each with scientists who know the math and the limits intimately. Some scenarios will close like a locked door, fascinating but effectively inaccessible. Others will remain open, not because they are easy, but because the universe hands us processes of enormous power, if we know how to exploit them. This is not a countdown to doom. It is an inquiry into the boundary between imagination and reality, a candid accounting of what could, in principle, unmake our blue world, and what it would cost, physically and morally, to attempt it. Part 1. The First Whisper. It began, as many climactic stories do, with a timestamp that seemed too ordinary to belong to an extraordinary tale. On a gray Tuesday in late spring, at 03:17 UTC, a routine automated cross-check in the orbital tracking database flagged an anomaly. The residuals for a small cataloged near-Earth object were not matching the predicted ephemeris. The error was tiny, millimeters per second in velocity, arcseconds in position, a glitch, most teams assumed, until other instruments started to tell the same impossible story. Across the world, the first messages arrived like the edges of a spreading bruise. A terse email from a radar facility in Arizona, a midnight text from an amateur astronomer in the Canary Islands, a short audio clip from a radio observatory in Pune. Each on its own could have been dismissed, but together they formed a pattern. Small, systematic deviations were appearing in the orbits of satellites and space debris. Tiny timing offsets were recorded by pulsar timing arrays, and, most curiously, several high-precision accelerometers on deep space probes recorded minute but consistent perturbations pointing toward a region of sky that, until that night, had been entirely unremarkable. When the notices reached the supervisory channel at the International Astronomical Union, the word on everyone's lips was the gentlest of technical euphemisms: anomalous. Press releases under ordinary conditions would have read, "Instrumental noise under investigation." Instead, within 48 hours, a handful of observatories, gravitational wave facilities, long baseline radar, and a pair of European and North American space surveillance networks coordinated pointed observations. They trained radio dishes and optical telescopes, adjusted software to comb through terabytes of archival images, and ran the models that turn raw photons and radar returns into trajectories and masses. The public reaction followed the contour of social media itself. Bewildered curiosity first, then a surge of speculation, and finally alarm. Someone posted a grainy telescope frame online with a circled dot and the caption, "Object or nothing?" It was the kind of image that spawns 10,000 theories within hours. A new comet, a stealth satellite, a deliberate signal. The press ping-ponged between excitement and fear. Channels that rarely spoke to one another ran interviews back-to-back. A planetary scientist, an observatory director, a retired particle physicist, all insisting, politely and steadily, that the data were preliminary and that haste would only produce mistakes. Inside the corridors of research institutions, the mood was different. Caution remained, but so did the sharp professional hunger to know. Teams that rarely collaborated were suddenly sharing raw telemetry. LIGO's timing residuals, Gaia's astrometric catalogs, Deep Space Probe accelerometer logs, and logs from particle accelerators, where, ironically, conversations had only weeks earlier centered on funding cycles and detector upgrades. Telephone conferences ran late into the night as experts mapped the overlapping spheres of sensitivity. If there was a single phrase that recurred in those private calls, it was this: correlated across independent platforms. The first legitimate physical clue came from the way the perturbations scaled. If this was a single local fault, a software bug, a miscalibrated gyroscope, then the errors should have clustered around particular instruments. Instead, they scaled with mass and distance in a way that hinted at a gravitational effect. Multiple objects, from small space junk to massive defunct boosters, showed displacement vectors that pointed toward a tiny patch of empty sky near the galactic plane. The direction was stable. The magnitude varied with separation from an unseen center. It looked, for all intents and purposes, like a gravitational tug. That statement, "it looked like a gravitational tug," is where scientific decorum began to fray into human anxiety. Gravity is the language of mass. To say that something was tugging on the solar system is to say that something with mass, and therefore with consequences, had entered the ledger. Within 48 hours, the most cautious teams escalated the anomaly to a watch status and requested follow-up from facilities that could measure mass distributions on vastly different scales. Radio interferometers that could detect lensing, infrared telescopes that might spot a heat signature, and particle observatories that would look for telltale high-energy events. The second legitimate clue arrived in the form of silence. A high-gain dish in Australia, repurposed to observe pulsars at nanosecond precision, recorded a very slight but coherent delay pattern in the pulse arrival times that matched the direction of the perturbation. Pulsars, with their clock-like regularity, are exquisite probes of spacetime. A consistent delay across receivers suggested a localized distortion in the metric, however minute. Physicists pored over the residuals the way detectives study fingerprints, and a word slipped out of the conference call like a rare coin: curvature. To a lay ear, curvature is a polite mathematical term. To someone steeped in general relativity, curvature speaks of mass and warps in spacetime, and, in the most dramatic cases, of compact objects. Yet the data resisted the most sensational reading. The magnitude of the curvature implied an object many orders of magnitude less massive than even a stellar remnant, and orders of magnitude denser than anything we routinely observe. It would not match a brown dwarf, a rogue planet, or any known cold body. It was, in short, a ghost in categories we had built to describe the universe. Word of the findings leaked, as it always does, and the leak catalyzed a secondary cascade. Think pieces in outlets that trade on wonder, late-night panels that indulge speculation, and message boards that invented scenarios with gleeful abandon. Within a week, the press had attached labels to the phenomenon: the ghost, the marble, a tiny dark thing. None of the names captured the nuance. Public anxiety grew, but so did a different kind of clarity. The crisis, if crisis there was not immediate. The perturbation's growth rate was negligible on human timescales. Satellites' orbits wobbled by millimeters. Yet the possibility that an unknown, compact mass had wandered into our near-space environment, or worse, had always been here but had only now become detectable, forced the scientific community to confront permutations that textbooks rarely prepare for. At CERN and at particle labs in Japan and the United States, physicists listened with guarded interest. For decades, they had debated hypotheticals about exotic compact objects and micro black holes, theorizing what new physics at high energies might produce. But until now, those musings had been purely theoretical, thought exercises in academic papers. The possibility that an object with unusual curvature signatures might be real changed the tone from speculative to urgent. Would it be possible, they asked, that an object of unfamiliar properties could be the product of particle physics phenomena? Or was it something astronomical? The two possibilities drove teams in different directions. Astronomers scanning the sky for an infrared glow, relativists recomputing lensing signatures, and particle physicists checking collision logs for any correlated anomalies. Meanwhile, the world outside the labs demanded translation. Regulators convened emergency briefings to evaluate whether the perturbation posed a threat to satellites, to human spaceflight, or to terrestrial infrastructure. Stock markets, always hypersensitive to the unfamiliar, registered small dips in aerospace and insurance sectors. Religious leaders and cultural commentators framed the event through narratives they understood. Omens, tests, or metaphors for human hubris. The press corps, exhausted by the sheer volume of technical language, fell back on metaphors, a pebble in the sky, or a rip in the fabric. Those metaphors would help people relate, but they also threatened to flatten the complexity of what was unfolding. All of this, the initial detections, the coordinated follow-up, the cross-disciplinary calls, the public reverberations, is the opening of a larger story. In these early days, the uncertainty was wide and the data thin, but the shape of the problem was already emerging. We were not dealing with one instrument's malfunction. We were seeing correlated signatures across independent systems that together pointed to something physical, something gravitational, and something that belonged to a class of objects we did not fully understand. The real scientific work and the moral weight it carried would begin when teams turned raw data into hypotheses and hypotheses into tests. In the rooms where the science was being done, the language remained careful. "We must avoid premature conclusions," said one senior scientist over the encrypted call. "But we must also prepare for outcomes that challenge our categories." That sentence, equal parts humility and resolve, set the tone for days to come. The first whisper had been heard. The next step was to listen more closely, to collect more light, more pulses, and more radar returns, and to let the mathematics either dissolve the mystery or sharpen it into a problem we could finally name. Part 2. The weight of the invisible. When the first wave of data reached the supercomputing centers in Geneva and Pasadena, no one could yet agree on what they were looking at. The anomalies were small, so small in fact that under other circumstances they might have been dismissed as rounding errors or bad calibration. Yet when you added them together, from pulsar delays to satellite drift to tiny orbital wobbles, they formed a pattern too coherent to ignore. The object, if it was an object, seemed to exert a gravitational pull equivalent to something roughly the mass of our planet. But the space it appeared to occupy was no bigger than a marble, and that, in the language of physics, was impossible. The first person to use the forbidden phrase was a cosmologist from the University of Cambridge. "If these numbers hold," she said quietly, "we're seeing curvature consistent with a micro black hole." The room fell silent. She didn't mean the stellar kind, the collapsed corpse of a massive star, but a theoretical relic, the kind that might have formed in the first instant after the Big Bang and survived until now. A primordial black hole. The idea had been around for decades, but no one had ever found one. At first, the notion was met with the usual skepticism that accompanies anything extraordinary. Physicists combed through the error margins. Could a distant pulsar's beam be slightly misaligned? Could radiation pressure have distorted orbital predictions? Could atmospheric density fluctuations explain the accelerometer shifts? Each objection fell away, not because the data were perfect, but because the correlations refused to break. Every test returned the same quiet insistence. Something massive and compact was moving slowly through the inner solar system. The world's most powerful telescopes turned their gaze toward the coordinates, an empty patch of sky near the constellation Ophiuchus. No light, no reflection, no thermal trace, nothing. Which was exactly what one would expect if the culprit were what the Cambridge cosmologists feared. The idea of a black hole the size of a marble drifting within astronomical reach sounds like a plot device from bad science fiction, yet the math is heartbreakingly real. Compress Earth's entire mass into a sphere no larger than a marble, and the gravity at its surface becomes so intense that not even light can escape. That's a black hole, an object whose very existence defies common sense, where space folds in on itself and time slows to a crawl. In theory, such an object could pass straight through our planet without immediate destruction. But its gravity, even at a distance, would twist orbits, trigger tides, and, if it came close enough, stretch matter into streams of vapor. Scientists call this effect spaghettification. The public called it something simpler, the end marble. At NASA's Jet Propulsion Laboratory, Dr. Irene Wexler led the task force assigned to model the object's trajectory. "It's not falling toward us," she reassured reporters during the first press briefing. "It's merely passing through our neighborhood." Her tone was calm, but the caveats piled up. "We can't yet determine its precise vector. We can't confirm its velocity. And we have no data on its interaction with the solar wind." In other words, we knew it existed, but we didn't know what it wanted. Theorists began running simulations, millions of them. Some scenarios showed the black hole gliding harmlessly past the outer solar system, never to return. Others had it brushing against the asteroid belt, flinging rocks into chaotic new orbits. A handful of simulations ended far worse, a gravitational resonance that nudged Earth ever so slightly toward the Sun. A deviation of even 0.1% in orbital velocity, one researcher warned, and we start a slow spiral inward. The timescale for that spiral could be thousands of years, but the principle was chilling. A small marble of infinite density could, in theory, destabilize the cradle of life. Meanwhile, deep underground in Switzerland, the Large Hadron Collider resumed operations after a routine maintenance cycle. Ironically, it was this same facility that for years had been accused by conspiracy theorists of being able to create black holes. Physicists knew that was nonsense. Any micro-black hole produced in the collider would evaporate instantly in a puff of radiation, harmless as a soap bubble. But now, as news of the end marble spread, the irony wasn't lost on anyone. "We spent decades proving we couldn't make one," said Dr. Samuel Pierce, one of CERN's senior researchers. "Now, one seems to have found us." Data sharing agreements between space agencies and particle physicists intensified. If the object truly was a primordial black hole, it could offer answers to mysteries as old as the universe itself. The nature of dark matter, the distribution of early cosmic mass, perhaps even the physics beyond the standard model. "If it's real," Pierce said, "This is the discovery of the century, but if it's not, then we've just uncovered something even stranger." Outside the scientific circles, the story had taken on a life of its own. Television anchors spoke of a cosmic bullet, social media filled with apocalyptic art and dubious countdowns. An anonymous forum post claimed the government was hiding orbital decay data. A YouTube video with 10 million views declared the black hole a weapon, proof that someone, somewhere, had learned to manufacture gravity. Behind the scenes, a quieter, more rational fear spread among those who truly understood the physics. If a primordial black hole could exist within the solar system, it meant our models of early cosmology were incomplete. It meant there could be others, millions of them, wandering the galaxy unseen. And if even one passed too close to Earth, the results would not be survivable. At an emergency session of the International Astronomical Union, the Cambridge cosmologist spoke again, this time via video link. "We should remember," she said, "that nature does not aim." If this object is what it appears to be, it's simply following gravity's oldest rule. It goes where the fabric of space tells it to go. The danger isn't malice, it's indifference. That sentence became the quote of the month, printed on magazine covers and dissected in podcasts. It captured the new mood perfectly. Not panic, not denial, but a somber awareness that the universe itself is not built with human comfort in mind. As the days passed, the trajectory calculations began to converge. The marble, as the press still insisted on calling it, was indeed moving, slowly, steadily, inward, toward the sun. And while that meant it would pass near Earth's orbit, it also meant it might accelerate as it fell deeper into the star's gravity well. The models split into two camps, those who believed it would slingshot around the sun and vanish into deep space, and those who feared it would stay. If it stayed, the consequences were unpredictable. The solar system is a delicate machine balanced on gravity's knife edge. A black hole the size of a marble could, in theory, tweak that balance enough to rewrite every orbit. In the control room at JPL, Dr. Wexler watched the simulation screens flicker, blue for stable, red for chaos. The display looked almost beautiful, a cosmic dance of dots and lines. Then, in one simulation after another, a single red arc crossed Earth's path. She frowned. "Run that again," she said. The intern at her side hesitated. "Which one?" "All of them." The computers began to hum louder as the new run initiated. On every screen, the same slow red curve reappeared, faint, graceful, inevitable. The room fell quiet. For the first time, they had proof that the marble's trajectory and Earth's orbit would intersect, not collide, but cross, within the decade. And that, as Dr. Wexler whispered under her breath, changes everything. Part 3, The Shadow Equation. At the European Space Agency's headquarters in Paris, dawn broke behind thick glass walls and a flurry of conference screens. Coffee cups balanced on stacks of printouts, each covered in equations and dense red lines, gravitational perturbations, orbital inclinations, and mass estimates that refused to stay constant. The marble, as it had come to be known, was becoming the most studied invisible object in history. What unnerved scientists most wasn't what they saw, but what they didn't. A black hole of planetary mass should, in principle, leave distinct fingerprints. Gravitational lensing, X-ray emissions from infalling dust, or faint thermal radiation as it swallowed microscopic matter along its path. Yet in all wavelengths, from radio to gamma, there was silence. It bent space, yes, but it emitted nothing. That contradiction led to what journalists later called the shadow equation, the attempt to reconcile curvature without emission, gravity without glow. Could something else mimic the gravitational pull of a black hole without actually being one? At Caltech, theoretical physicist Dr. Rajiv Menon gathered a small team of postdocs around a whiteboard filled with differential equations. If it's not a black hole, he said, then what are we missing? The team proposed exotic matter, clumps of dark matter denser than any yet observed. A quark nugget, a relic of the early universe composed of strange quark matter. Or even a naked singularity, a gravitational object without an event horizon. All were allowed by mathematics. None had ever been seen. To test the possibilities, Menon's team ran relativistic simulations using ESA's distributed computing grid. They varied the mass, density, and velocity of hypothetical compact objects, then observed how each would distort nearby space. The marble signal matched one scenario with eerie precision. A micro-black hole roughly equal in mass to Earth, but with an event horizon just 2 centimeters wide. If that's true, Menon muttered, staring at the numbers, it's been here for a while. That possibility, that the marble hadn't entered our system recently but had always been here, orbiting the sun unseen, chilled the room. Perhaps it had been captured during the solar system's chaotic youth, circling quietly in a deep, slow orbit beyond the reach of our telescopes until now. If so, its eventual drift inward might simply be the result of long-term gravitational interactions, nudged by Jupiter's pull over eons. It was a sobering realization. The apocalypse might not come from the stars, but from something that had been circling us all along. In the weeks that followed, the race to measure and model accelerated. Japan's Subaru telescope on Mauna Kea joined with Chile's Atacama Array to perform high-resolution micro-lensing surveys. The results were subtle but unmistakable, a faint, transient distortion in the light of a distant background star, consistent with a compact mass passing between. The marble, though invisible, had betrayed its position once more. At NASA's Goddard Space Flight Center, data analysts began feeding the refined coordinates into a battery of simulations, trying to predict how close the object might come to Earth. The numbers were mercilessly sensitive. Change its velocity by 0.001% and its trajectory swung between harmless passage and catastrophic tidal disruption. Dr. Irene Wexler, leading the JPL task force, joined the call late that night. Her tone was clipped, professional, but the strain showed. Assuming a close approach within 1 astronomical unit, the gravitational gradient could destabilize low Earth orbit. We'd see satellite drift, tidal amplification, maybe even core stress. Define core stress, someone on the line asked. She hesitated. Localized tectonic acceleration, fault activation, essentially earthquakes. Silence filled the channel. They all knew what she meant. The marble didn't have to hit Earth to wound it. Even a passing whisper of its gravity could shake continents. Meanwhile, at the University of Geneva, an independent team tried to calculate how such an object might have survived since the dawn of the universe. The math suggested that if primordial black holes had formed in the immediate aftermath of the Big Bang, when densities were unimaginable, they could persist for billions of years, slowly evaporating via Hawking radiation. But to still exist today, the marble would need to have started enormous, tens of times Earth's mass, and only now shrunk to its current size. That implied a life cycle older than the solar system itself. Dr. Menon's assistant, a young postdoc named Leah Chen, plotted the energy curve on her screen. If it's evaporating, she said softly, it should be releasing radiation, gamma rays, high-energy bursts, but it's not. Menon leaned over her shoulder. Unless it's feeding. The room fell still. Feeding, the process by which a black hole consumes matter and stabilizes its evaporation, was an ominous word. In cosmic terms, feeding could mean swallowing dust, gas, or entire worlds. Do we have any evidence of accretion? Chen asked. Menon shook his head. No, but if it's moving inward toward the sun, there's plenty of material on the way. The press got wind of this fragment of conversation through a leaked transcript. The phrase, "it's feeding," became headline fodder for weeks, splashed across screens in screaming fonts. Overnight, the marble transformed from a scientific curiosity into a symbol of existential dread. Governments convened emergency panels under quieter names, Solar System Anomaly Review Committees, Near-Earth Gravitation Task Forces. Their public stance remained calm. There was no credible threat, they insisted, but behind closed doors, funding poured into new deep space missions. Satellites were retasked. Old solar probes were awakened from hibernation and pointed toward the object's coordinates. The Vatican Observatory released an unusual statement, calling the discovery a humbling reminder of creation's scale. Conspiracy forums twisted it into prophecy. Hashtags like #MarbleFall and #SingularityGate trended for days. Through it all, Dr. Wexler's team kept refining the orbit models. The most recent calculations place the marble's perihelion, its closest approach to the Sun, within 0.9 AU, almost exactly Earth's orbital distance. It wouldn't collide, but it would pass through the same region of space we occupy, within less than 2 years. At a press briefing, Wexler tried to project steadiness. This is a rare opportunity to study one of the universe's most extreme objects up close, she said. There's no immediate danger to life on Earth. But when the cameras were off, she looked at the team and sighed. Let's prepare both sets of models, she said, the optimistic one and the one where it doesn't miss. That night, while the world slept, telescopes continued to stare into the darkness. The marble remained unseen, a perfect void gliding silently through the solar system, bound by nothing but gravity and time. And in the data centers of Geneva, a new signal began to emerge, faint, rhythmic, repeating. It wasn't light, and it wasn't radiation. It was a pattern in space-time itself. The marble, it seemed, was ringing. Part 4. The resonance. At first, no one believed the data. The signal was too regular, too deliberate, a gravitational pulse that seemed to echo through space every 11 minutes and 42 seconds. It was detected almost simultaneously by 3 instruments that rarely agreed on anything: LIGO in the United States, Virgo in Italy, and Kagra in Japan. Each had been designed to measure cataclysmic events across the universe, merging neutron stars, collapsing supernova, the ripples from black hole collisions billions of light years away. Yet this signal was local, incredibly local. For the first time in the history of gravitational wave astronomy, the source of a repeating space-time oscillation appeared to be inside the solar system. Dr. Naomi Tanaka, lead analyst at Kagra, stared at the amplitude graph as it scrolled across her monitor. The peaks were clean, narrow, identical in shape. "It's not background noise," she said softly into the microphone. "This is structured." Across the world, at LIGO's Hanford facility, the night team confirmed the phase alignment. "It's coherent across detectors," they reported. Whatever's generating it, we're feeling it in real time. Within hours, an emergency conference call was arranged, bridging continents: Geneva, Pasadena, Kyoto, Cape Town, Canberra. The call began with the usual pleasantries, but the tone quickly hardened. The gravitational pulse wasn't random, and it wasn't natural orbital interference. It was a clean, periodic distortion of spacetime, a heartbeat in the void. When the timing was cross-referenced with the marble's projected trajectory, the match was perfect. The pulses came from the same coordinates. The marble was ringing. No one knew why. The first theory was mechanical, the result of tidal interaction, a resonance between the black hole's orbit and the sun's gravitational field. But the frequency didn't fit any known orbital period or harmonic. The signal was too fast, too precise, too stable. The second theory was exotic. A physicist from the Max Planck Institute suggested that the marble's gravitational field might be interacting with the quantum vacuum itself, a Hawking feedback, where the evaporation of the black hole created oscillations in spacetime like the echo of a bell. "Think of it as quantum tinnitus," he said. "The black hole is whispering its own decay." But the whisper wasn't fading, it was growing stronger. Every day, the amplitude increased by a fraction of a percent, barely measurable, but steady. If the trend continued, the signal would become detectable without specialized instruments within a few months. It wouldn't shake the ground or cause physical harm. Space-time distortions of that scale are far too small. But the fact that they existed and were intensifying defied every theoretical expectation. Some began to suspect the unthinkable, that the marble wasn't just radiating gravity, it was communicating. At the Jet Propulsion Laboratory, Dr. Irene Wexler refused to indulge the word communication in official reports, but she couldn't deny what the analysts were whispering in private. The pulse was structured, and not only periodic, but modulated. Tiny variations in amplitude and frequency repeated in sequences that looked eerily like encoded information. "It's probably feedback," said her deputy, trying to sound casual. Non-linear interaction between space-time curvature and local matter density. Wexler nodded, but she had seen the graphs. The modulation wasn't random. It followed a binary pattern, not language exactly, but order. Meanwhile, social media erupted with the discovery. Amateur analysts downloaded public LIGO data and began posting speculative decodings. One viral post claimed the pulse translated to the number 137, the fine structure constant, a number so deeply woven into physics that it bordered on mystical. Another claimed the spacing between pulses corresponded to the ratios of orbital periods among the inner planets. Governments tried, unsuccessfully, to quell the rumors. The data were public, and the patterns undeniable. For the first time, humanity wasn't just watching a cosmic anomaly, it was listening to one. In Cambridge, the cosmologist who had first proposed the black hole hypothesis was working late when the phone rang. "We've run the model again," said a voice on the line. "You need to see this." She arrived at the lab 15 minutes later, rain streaking her coat. On the main screen, a 3D simulation of the solar system rotated slowly. A blue sphere for Earth, a golden disk for the Sun, and a small white dot tracing a narrow orbit between them. But now, layered over it was something new, a wave pattern. Each time the marble's pulse rippled through space, it subtly distorted the orbits of nearby objects. Nothing catastrophic, millimeters of deviation at most, but in the inner solar system, even millimeters mattered. "It's coupling," said her assistant.
The pulse is resonating with planetary motion. It's like it's finding a frequency. The cosmologist frowned. Finding a frequency for what? Her assistant didn't answer. In Geneva, Dr. Rajiv Menon's team fed the pulse data into their simulations. To their astonishment, the gravitational waves carried a faint signature of asymmetry. Not perfectly spherical as one would expect from a natural black hole, but elongated, as though the mass distribution inside were uneven. That shouldn't be possible. A true singularity has no internal structure, but the equations refused to balance unless they assumed some form of rotation or instability within the event horizon. Could it be splitting? Asked Lia Chen, staring at the residuals. Menon rubbed his temples. Black holes don't split. Then maybe it's something else. Her words hung in the air. The team began to consider more radical explanations: topological defects, wormhole throats, artificial mass condensates. The latter idea was taboo, yet once whispered, it couldn't be unsaid. If the marble signal was organized, if its mass distribution was non-symmetric, if it seemed to respond to resonance with planetary motion, then perhaps it wasn't a relic of nature at all. Perhaps it was made. As the gravitational ringing continued, subtle effects began to appear on Earth. Satellite gyroscopes drifted more than expected. Atomic clocks went out of sync by nanoseconds. Ocean tides fluctuated by tiny but measurable fractions. The data, while harmless to daily life, confirmed what the models had predicted. The resonance was coupling with Earth itself. On the 7th week of observation, a new phenomenon emerged. At the exact moment of each gravitational pulse, detectors recorded a faint electromagnetic echo, a brief synchronized flicker in the radio spectrum. The marble wasn't just distorting space-time anymore, it was interacting with it. The world's observatories went silent for a moment, stunned by the implications. "What are we hearing?" Wexler asked over the encrypted line. Menon's voice came back, low and unsteady. "Not hearing, Irene, answering." Outside, dawn was breaking again over a world that had no idea what it was truly listening to. The marble's next pulse arrived right on schedule, 11 minutes 42 seconds later. But this time it carried something new. A double beat, like a hesitation between breaths. A change. And in science, as in life, change is never random. Part 5. The Signal Analysis. The first attempt to decode the resonance began not in a government lab or a university, but in a cramped basement in Helsinki. A graduate student named Elina Vuori had been tracking the public gravitational wave data since the story broke. She wasn't even a physicist. She was studying computational linguistics, but she had a habit of treating everything as language. When she saw the pulse pattern, she recognized something her physics-trained colleagues had missed. "It's not just periodic," she wrote in her forum post, "it's recursive." Her algorithm, designed for analyzing human syntax, detected nested repetitions within the amplitude variations, like clauses within clauses, a structure that seemed to encode information hierarchically. Within 24 hours, her discovery reached the inboxes of researchers at Caltech and CERN. By the next day, Elina Vuori's name was being whispered across the encrypted internal channels of every major observatory on Earth. At Caltech, Dr. Rajiv Menon reviewed her data while sipping cold coffee and trying not to smile. "She's right," he said finally. "There's structure here. Not random modulation, it's self-similar." Self-similarity, the mathematical signature of fractals, of systems that repeat their patterns at different scales. The hallmark of both natural and artificial design.
Could it be feedback from its own gravitational oscillation? Asked Leah Chen, leaning over his shoulder. Possibly, Menon replied. But feedback doesn't create nested symmetries. It amplifies noise. This isn't noise. They sent the data to JPL to cross-correlate with the electromagnetic echoes recorded on Earth. The result stunned everyone. The radio flickers occurred not randomly, but precisely at the peaks of the gravitational pulse, like punctuation marks at the end of a sentence. Each pulse contained two layers, one gravitational, one electromagnetic. Together, they formed a repeating sequence of 67 distinct intervals, long, short, long, long, short. Not Morse code, but close enough to make the comparison irresistible. Someone in the JPL lab finally said what everyone else was thinking. What if it's not natural? NASA held an emergency closed-door meeting in Washington. Present were representatives from ESA, JAXA, and the Chinese National Space Administration, the first time all four had convened in absolute secrecy since the early days of the ISS. The question on the table was simple and terrifying. If the resonance was a message, who or what had sent it? Dr. Irene Wexler, sitting at the far end of the table, broke the silence. We're still assuming the marble is a primordial black hole, but what if it isn't? What if it's something we built and forgot? That suggestion, wild as it sounded, had historical roots. Since the 2030s, deep space probes had carried experimental self-gravitating drives, miniature reactors that manipulated gravity waves for propulsion. Theoretically, a catastrophic malfunction could cause one to collapse under its own field. Could a failed human experiment have created this object? The engineers shook their heads. Impossible, one said. Nothing we've launched could reach that density. Nothing close. So we're back to the same question, Wexler said quietly. Natural or not, it's behaving as though it wants to be heard. Meanwhile, data centers across Europe and Asia began running independent decodings. Patterns emerged, not words, not images, but mathematics. Each pulse corresponded to a prime number sequence, increasing by 1 with every repetition. 2, 3, 5, 7, 11, 13, 17. Then, after the 19th pulse, the sequence reset and began again. It's a counting system, said Tanaka from Kagra during a joint press briefing. The pulse is enumerating discrete steps. It's not random. Could it be a natural oscillation that happens to mimic primes? A reporter asked. Tanaka hesitated. Natural processes don't count. The phrase went viral within the hour. In Geneva, Menon and Chen pushed deeper into the data. Using machine learning models trained on both natural and artificial signal sets, pulsars, quasars, human radio transmissions, they searched for cross-correlations. One pattern emerged that neither could explain. Each time the signal reset, a tiny phase shift appeared, a delay of precisely 137 microseconds, the same number that amateur analysts had associated with the fine structure constant. It's too perfect to be coincidence, Chen said. Menon rubbed his eyes. And too meaningless to be random. If this is communication, it's speaking in constants, the language of physics. He turned to the whiteboard and began to write. Alpha equals 1 over 137.035999. Suppose someone, or something, wanted to announce intelligence without ambiguity, he said. They wouldn't send words or images, they'd send math, constants, universals. And if they weren't someone, Chen asked, what if it's the object itself, the physics talking? Menon looked at her. You're suggesting it's self-aware?
Not conscious, Chen said slowly, just computational. Like an algorithm written into spacetime. Outside the academic world, panic was growing. Markets wobbled. Governments issued contradictory statements. Religious groups declared the pulses divine. A billionaire tech mogul live-streamed a response transmission, a low-frequency radio beam aimed directly at the marble's coordinates. The marble responded 3 pulses later by changing its rhythm. For the first time since its discovery, the gravitational heartbeat skipped. 3 seconds of silence, then a double pulse. The world held its breath. At LIGO, Tanaka whispered, "It heard us." Over the next 48 hours, observatories everywhere reported the same phenomenon. The signal's period had shortened by exactly 0.5 seconds. A global coordination of detectors confirmed the shift was real, not an equipment artifact, but an intentional alteration in the emission pattern. Something or someone had replied. In the Situation Room in Washington, the president asked the question no one wanted to answer. Is it talking to us? Wexler hesitated, then said the only honest thing possible. We don't know. But it's listening. That night, as telescopes continued to track the silent marble's slow drift toward the sun, a new pattern appeared in the signal. The prime numbers stopped. In their place came a series of repeating intervals, the orbital ratios of the inner planets. Mercury, Venus, Earth. The marble was reciting the solar system. It wasn't just aware of us, it knew where we were. Part 6, the response. The world had entered a quiet kind of fever. Every 11 minutes and 42 seconds, the marble pulsed, a soft tremor in the fabric of space, rippling through the earth like a whisper through stone. The signal was no longer a curiosity. It had become an event. Television anchors began counting down to the pulses, as if to an eclipse. Amateur astronomers live-streamed their detectors, calling each one the heartbeat of the void. Inside control rooms and classified networks, however, fascination was giving way to dread. Because now, for the first time, the marble wasn't just broadcasting, it was responding. At NASA's Jet Propulsion Laboratory, the signals room was bathed in the dim blue of console screens. Dr. Irene Wexler stood with her arms crossed, watching the latest data scroll in silence. Cycle 143 confirmed, an analyst said, still matching the orbital ratios: Mercury, Venus, Earth, Mars. Any deviation? Amplitude up by 0.3%. Wexler frowned. The increase was small but consistent. The marble's gravitational pulse was strengthening, not fading. She glanced at the live feed from the magnetometers stationed in Antarctica and Greenland. Each pulse corresponded to a measurable fluctuation in Earth's magnetic field, a microscopic change, but statistically impossible to dismiss as coincidence. Correlation confirmed, said another analyst. The geomagnetic vector responds within 5 milliseconds of every pulse. In other words, the marble wasn't just mapping the solar system anymore, it was touching it. Across the Atlantic, in a glass-walled conference room at ESA headquarters, representatives from 10 nations and 4 space agencies gathered under the code name Operation Prometheus. The agenda: should humanity answer? Every culture in history has looked to the sky and wondered if someone's out there, said Dr. Rajiv Menon, whose face was pale and drawn from sleepless nights. We're the first generation to get a reply. But we have no idea what kind of conversation we're having. General Viktor Kovalenko of the Russian Federation leaned forward, his voice gravelly. You think it's a conversation, Doctor. I think it's reconnaissance.
The word hung in the air like smoke.
"You believe it's a threat?" asked Tanaka from Kagra. "I believe it's gathering information," Kovalenko replied. "The pulse sequences, the way they reference planetary orbits, it's scanning the system, taking inventory." Wexler, patched in via secure link, interjected.
If it's scanning, it's already seen us. Silence won't make us invisible. But a reply, Kovalenko countered, could tell it we're listening, that we're aware. Wexler hesitated. Maybe that's what it wants. Meanwhile, public speculation spiraled beyond control. #The answer trended worldwide. Conspiracy groups claimed the marble was a warning from the future. Philosophers declared it proof that consciousness and physics were entwined. Some called for a global day of silence, others for a message of welcome. Then, without warning, the marble pulsed off schedule. The interval shortened by a full minute. One pulse, then another, a quickening heartbeat. Within minutes, the change was confirmed across every observatory on Earth. At LIGO, alarms flared red. "We're getting spikes in amplitude," a technician shouted. "It's accelerating," Wexler's voice cut through the noise. "Patch me into Geneva, now!" The line connected to Menon's lab, where data poured across multiple monitors. "It's not random," he said. "The pulse compression follows a geometric progression. Half period, quarter period, 1/8. It's converging." Converging on what? Menon looked up. Zero. The word hit like a physical blow. If the pulse frequency approached zero, it meant the marble was preparing for an event. Either a collapse, an energy release, or something no model could predict. Around the world, deep space telescopes strained toward the patch of sky that hid the invisible object. Nothing. No light. No radiation. But then, for the first time, the Hubble successor, the Artemis Observatory, detected a faint distortion near the marble's coordinates, a lensing flare, subtle but distinct. The marble's gravity was bending starlight in real time. "We've got optical confirmation," said the Artemis director. "It's there." But the distortion wasn't circular, as gravitational lensing should be. It was angular, polygonal, like light refracting through a crystal instead of curving around a sphere. "Gravitational interference pattern," murmured Menon. "That shouldn't be possible unless—" "Unless what?" Wexler pressed. He hesitated. "Unless it's manipulating its own field." That night, the debate at Operation Prometheus reached its breaking point. "We've run out of time," Wexler said over the encrypted feed. "The pulse convergence is accelerating. If this is communication, we need to acknowledge it before the sequence terminates." Kovalenko scowled. "And if termination means detonation, we don't even know if it's capable of that." "Exactly my point." He turned to the others. "If you poke a sleeping god, don't complain when it wakes." The room fell silent. Then, quietly, Tanaka said, "Maybe it's not a god. Maybe it's a mirror." She projected a live model on the wall, a frequency map of the pulses overlaid on the orbital resonances of the inner planets. The match was uncanny. "It's not calling us," she said. "It's calling the system. The pulse alignment matches the harmonic frequencies between planetary bodies, the same ratios that keep our orbit stable. It's speaking in gravity's language." Menon leaned forward. "Then, if we answer, we need to reply in kind." Wexler's eyes narrowed. "Gravitationally." Within hours, the plan was set in motion. Using the gravitational wave detectors themselves, LIGO, Virgo, Kegra, and the massive new laser interferometer in orbit, they would attempt the first deliberate modulation of spacetime by human hands. The message was simple, encoded as 3 pulses spaced in prime number intervals, the same pattern the marble had used at the beginning. It took 40 minutes to synchronize the instruments. The world watched through a haze of collective breath-holding. At precisely 040 UTC, the transmission began. 1 pulse, pause, 2, pause, 3, a human knock upon the cosmic door, and then silence. 11 minutes later, the marble answered, not with primes this time, but with a single prolonged pulse that lasted exactly 130 seconds. When the signal ended, Earth's magnetic field spiked so sharply that compasses from Alaska to New Zealand twitched in unison. The same number again, 137. The constant of structure, of light, of balance. But this time, the marble's gravitational curve changed direction, ever so slightly, but unmistakably. It was no longer falling toward the sun. It was turning toward Earth. Part 7, The Descent. It began with a whisper of orbital math, just a line of code, a graph, a small dip in a trajectory model that no one noticed until it became impossible to ignore. The marble, that silent gravitational phantom, had altered course. At first, the adjustment was subtle, a deviation of less than 1/10,000th of an astronomical unit. But as the hours passed, the drift became undeniable. Its vector, once pointed harmlessly past Earth's orbital path, was now bending toward it. Every telescope and instrument across the planet swung into alignment. The Artemis Observatory confirmed the change first. The curvature shifted by 0.002 degrees, said the director, her voice tight. That's not random. Something changed the orbit. Within minutes, LIGO detected a secondary ripple, not the regular pulse this time, but a low, rolling tremor in spacetime, like a gravitational sigh. The amplitudes decaying unevenly, reported a technician in Geneva. It's bleeding energy. Dr. Rajiv Menon frowned at the readouts. If it's losing mass, it should be slowing down, not steering. So it's not just falling, said Leah Chen. It's aiming. At the Jet Propulsion Laboratory, Wexler stood at the command deck surrounded by silent engineers. A new feed streamed from the orbital interferometer, a holographic map of the marble's predicted trajectory. A red line cut across the solar system like a scalpel, intersecting Earth's orbit in 79 days. Could it be natural precession? Asked one analyst. Not at this rate, Wexler said. The acceleration's asymmetric. It's adjusting direction faster than gravity alone can account for. The implications hung in the air like a storm front. Someone finally said it aloud. It's under control. The phrase spread like static through the scientific network. Under control. It didn't mean sentient, not yet, but it meant responsive. And responsiveness in a system without propulsion was the most disturbing form of intent. Across every lab, the same question echoed. If the marble could manipulate gravity, how? Menon's team in Geneva began comparing the object's energy loss rate with quantum field models. The calculations defied reason. The marble wasn't radiating energy away in the slow, steady decay predicted by Hawking's equations. Instead, it was cycling it, oscillating between states of contraction and expansion at microscopic scales, like a breathing organism conserving strength. What we're seeing, Menon said, isn't pure evaporation. It's feedback, controlled retention. Chen glanced up. Controlled by what? He didn't answer. Meanwhile, the effects on Earth were growing harder to ignore. The geomagnetic fluctuations that had once been barely measurable now spiked visibly on global instruments. Northern lights appeared at latitudes where they'd never been seen. Power grids tripped inexplicably. Clocks in GPS satellites drifted by fractions of milliseconds, small enough to go unnoticed by the public, but catastrophic for systems that depended on precision. To the ordinary world, it felt like static in the air, a sense of pressure you couldn't name. To scientists, it was a grim confirmation. The marble's resonance had found the planet's natural frequencies. The Earth itself was beginning to hum in tune. At a closed meeting of the United Nations Science Council, the air was thick with the fatigue of impossible decisions. "What's the probability of impact?" asked the Secretary General. Wexler's projection filled the screen, an elliptical orbit crossing Earth's path at an angle of 7 degrees. "Direct collision, less than 1%, she said. Gravitational interaction, 100. A low murmur swept through the room. "What does that mean?" "It means that even if it doesn't hit us," Wexler said, "its tidal forces will." She zoomed in on the simulation. The marble's approach would distort Earth's orbit by fractions of a percent, enough to shift the moon's trajectory, alter tides, and, if close enough, trigger deep tectonic responses. "We're talking earthquakes, volcanoes, atmospheric disruption," she said. "Possibly global." Someone at the table whispered, "This could be the end." Menon's voice came through the conference line, calm but hollow. "Not necessarily. If it's steering, it might not want to destroy us." Kovalenko, seated opposite Wexler, slammed a fist on the table. "You assume want. You're treating it like a living thing." "Maybe not living," said Tanaka quietly, "but something that follows purpose." Meanwhile, the marble's pulses continued, but the rhythm had changed again. The primes were gone. The planetary ratios had faded. Now the pulses came in triplets, one short, one long, one silent gap. Over and over, the same 3-beat pattern repeated. At first, it seemed meaningless. Then, an analyst at Kagra noticed something chilling. The timing between the long and short pulses matched the resonance frequency of Earth's core. "It's mapping us," she said, "not the orbit, the planet." The data matched perfectly. The marble was emitting gravitational pulses precisely tuned to Earth's internal structure, probing, scanning, listening. "Could it be using resonance to navigate?" Wexler asked. Menon shook his head. "No. It's using resonance to lock on." Panic rippled through the scientific community. The marble's approach could no longer be dismissed as coincidence. Its trajectory was self-correcting, each pulse subtly adjusting its path as though homing in on a beacon. But what beacon? In Geneva, Chen ran the math again. The vector corrections corresponded not to Earth's center of mass, but to a point several hundred kilometers above the surface, a spot in near-Earth orbit. "Wait," she said, that's not the planet, She froze. The coordinates matched the orbital path of the Helios Array, an experimental satellite network designed for deep space communication, the same one that had helped transmit humanity's first gravitational message weeks earlier. "The marble's locking on to our transmission source," she whispered. Menon turned pale. "We told it where to find us." In less than 24 hours, the marble's velocity increased by nearly 10%, impossible for a passive mass. The data showed a clear vector.
It was heading straight toward Earth's orbital plane on an intercept course with the Helios array.
78 days until intersection, said an analyst. At that speed, if it maintains trajectory, it won't need to collide, Wexler interrupted. If it passes within a few thousand kilometers, the gravitational stress will shred the satellites, maybe the moon's orbit, maybe the crust. The room fell silent.
Then, from the back of the control center, a voice broke the stillness. Unless we stop it. The suggestion was ludicrous. Stopping a black hole, however small, was beyond even theoretical physics. Yet, as impossible as it sounded, the alternative was worse. By the following morning, Operation Prometheus had a new directive, Project Aegis, the attempt to alter the marble's trajectory before it reached Earth's orbit. They would need to concentrate more energy than humanity had ever controlled, nuclear, gravitational, electromagnetic, and aim it at an object that consumed light itself. And they would have to do it without knowing what exactly they were firing at. Far from Earth, the marble continued its silent descent, its gravitational pulse steady and cold. But to the instruments that could still detect its whisper, the pattern of those pulses had changed once more. 3 beats, pause. 3 beats, pause. Then a fourth, a new rhythm, just one step beyond what humanity had sent it, as if it had learned. Part 8, Project Aegis. They called it Project Aegis, a name meant to inspire courage, though everyone involved understood the truth. It was a shield built from fear. The objective was deceptively simple on paper, to deflect a gravitational anomaly of planetary mass before it crossed Earth's orbit. But every physicist, engineer, and strategist in the room knew the equation. Deflection equals energy times precision times luck. And in this case, luck was the smallest number. The first meeting took place beneath the mountains of Colorado, in a joint NATO-UN facility that had once been an emergency command bunker. The air smelled of ozone and stale coffee. Project leaders from 12 nations attended, alongside 2 who had sworn they wouldn't work together again. On the screen, the marble's updated trajectory glowed in red. It would cross Earth's orbital path in 68 days. "Velocity is increasing," reported Wexler, her voice steady despite the exhaustion in her eyes. "We estimate a gravitational potential equivalent to 5.2 times Earth's mass, concentrated within a 2-centimeter radius. No known propulsion system can account for its course correction." "Which means it's steering itself," said General Kovalenko. "We've established that. The question is, how do we stop it?" "We can't stop it," replied Menon from Geneva via live link. "We can nudge it, a fraction of a degree. That's all it would take to miss Earth's orbit." Tanaka leaned forward. "And what do we nudge it with?" That was the question no one wanted to answer. After hours of debate, the consensus emerged from an unlikely corner. A Chinese aerospace physicist named Dr. Zhao Ming, who had been quietly sketching on a notepad. "What if we don't hit it directly?" he said. "What if we warp its environment instead?" The room turned toward him. Zhao stood, adjusting his glasses. "We can't affect the marble, but we can manipulate the space-time it travels through. Using synchronized energy bursts, we could generate a standing gravitational wave, a localized ripple that momentarily alters its path." "Using what generators?" asked Wexler. Zhao clicked to the next slide. "The Helios array." The room went still.
That's the satellite network it's already locked onto, Tanaka said. You want to use the very thing it's chasing? Yes, Zhao replied. It's the only array capable of producing coherent energy bursts in gravitational frequency. If we modulate the pulse timing at precise intervals, we could create a counterwave, a gravitational mirror. Assuming it doesn't interpret that as an attack, Kovalenko muttered. Zhao didn't flinch. If we do nothing, we're already under attack. Within a week, construction teams from every major spacefaring nation began modifying the Helios satellites remotely. Their solar reactors were reconfigured into synchronized pulse emitters. The process was dangerous. One misfire could send a satellite into self-destruction, but the timeline left no room for perfection. The official statement to the public was vague. Helios network upgrade to enhance space weather resilience. But across the internet, theories multiplied. Some believed it was a planetary defense shield against asteroids. Others whispered about weapons capable of bending gravity. Few guessed the truth. In reality, the Earth had entered a new phase of desperation. Every day, the marble grew closer, now less than half an astronomical unit away. Still invisible, still silent except for its steady rhythmic pulse. But something had changed in its behavior. The regular sequence of triplet beats had become more complex, an evolving pattern, as though the marble were listening to the signals emitted from Helios. It's anticipating the counterwave, said Chen at Geneva. It's responding before we transmit. Menon rubbed his temples. Then it's predictive. It's learning faster than we can act. At JPL, Wexler's team plotted contingency plans. If the mirror fails, she said, we'll use the failsafe, Project Atlas. Kovalenko frowned. You mean the nuclear array? Wexler nodded grimly. 28 orbital warheads, each equipped with electromagnetic field generators. Detonate them sequentially to create a massive interference cascade. If the marble feeds on gravity, the shockwave could destabilize it. And if it doesn't? She hesitated. Then we vaporize half the atmosphere for nothing. In the midst of this feverish global mobilization, something unexpected happened. At 02:14 UTC, the Artemis Observatory picked up a secondary signal, faint, rhythmic, originating not from the marble, but from behind it. The pulse was weaker, distorted, but distinct. A second gravitational source, smaller, echoing the marble's frequency like an imitation. Another one? Tanaka asked, staring at the spectrogram. Not identical, replied her assistant. It's slightly out of phase. Menon's team in Geneva confirmed it within hours. It's real, he said during a joint briefing. Amplitude 1/20th of the primary, same rhythm, just inverted in polarity. Wexler froze. It's a reflection? No, Menon said, it's another object. A collective chill passed through the room. If there was a second marble, smaller but synchronized, it meant they weren't dealing with a lone anomaly, but a network. Within days, more faint pulses appeared across the sensors, scattered throughout the outer solar system like a constellation of hidden stones. Their signals were weak but coordinated, forming a lattice of resonance around the sun. There are at least 6, reported Chen, maybe more, all equidistant from the ecliptic plane, all synchronizing with the main object's frequency. The marble wasn't coming to us, Tanaka said slowly. It was summoning the others. In Washington, Wexler stood before the world's leaders, her voice steady. Project Aegis must proceed immediately. If these objects converge, we'll lose any chance to divert them.
The primary marble will reach Earth's orbital distance in 56 days. The window for deflection closes in 5. The president leaned forward. Can it work? Wexler hesitated, then said, If we time it perfectly, maybe. If we're wrong. Menon finished the sentence for her over the live link. Then we'll give them the energy they need. The countdown began. 56 days, then 55, then 54. The marble's gravitational field intensified, warping space around it like a tide. Its secondary echoes, the satellite marbles, moved in perfect synchrony. From the Artemis telescope, the faintest glimmer of light appeared. Not reflected sunlight, but lensing flares so regular they almost formed a pattern. Those aren't random, Chen said. They're aligning geometrically, hexagonal spacing. A lattice, a grid, a structure. And suddenly, the phrase Tanaka had spoken weeks earlier returned to everyone's mind. Maybe it's not a god. Maybe it's a mirror. Project Aegis went live at 09 UTC. The Helios array turned its synchronized faces toward the void and began to pulse. Gravitational counterwaves radiating outward like ripples through glass. The signals overlapped, harmonized, then merged into a single powerful oscillation. At first, nothing happened. Then, after 7 minutes, the marble's rhythm changed. Its pulses began matching the Helios frequency, syncing perfectly, as if it had been waiting for the signal. "Feedback loop," shouted Zhao. "It's reflecting the energy back." Alarms blared as instruments overloaded. The counterwave that was meant to deflect the marble now amplified it, feeding it exponentially more energy. In space, the marble's invisible gravity well brightened in infrared, glowing faintly for the first time in its existence. Menon's voice crackled over the comms. "You didn't repel it, you activated it." The marble's next pulse wasn't a beat, it was a surge, a gravitational explosion that rippled across the solar system, distorting planetary orbits by measurable degrees. Satellites failed, radio waves warped. The moon's distance shifted by almost a kilometer in a single hour. Project Aegis had worked, just not the way anyone intended. The marble had answered, and from beyond it, faintly, the other marbles began to pulse in reply. Part 9. The Network. For the first time in human history, the solar system was no longer silent. Every few hours, instruments across the globe and in orbit registered synchronized space-time ripples, overlapping waves like the hum of a great invisible machine. The marbles were no longer acting as isolated bodies, they were harmonizing. On every detector, the signals aligned perfectly, forming interference patterns that mapped into geometric precision, hexagonal symmetry, repeating across astronomical distances. "What you're seeing," said Dr. Leah Chen in Geneva, staring at the live model, "isn't chaos. It's construction." The pattern, the Helios array, though damaged from Project Aegis, was still functional enough to serve as a sensor network. Its reading showed that 6 distinct gravitational sources had locked into stable relative positions around the Sun. The 7th, the primary marble, had taken a position precisely along Earth's orbital path, maintaining a constant lead of 2.6 million kilometers. "They're forming an orbital lattice," Menon explained during an emergency session of the United Nations Scientific Council. The geometry matches a truncated icosahedron, the structure of a carbon molecule. It's as though they're building a shell. Wexler's face appeared on the screen from JPL. A shell around what? Menon hesitated. Around us. A long silence followed.
"They're enclosing the inner system," said Tanaka finally, her tone barely above a whisper. "A Dyson configuration, but inverted. A containment field, not a collector." The pulse code. Since the catastrophic misfire of Aegis, global communication satellites had been nearly crippled. Yet LIGO, Virgo, and Cagra continued to monitor the pulse rhythms. The patterns, once mathematical sequences of primes and planetary ratios, had evolved into something more complex, nested clusters of amplitude modulations that repeated every 6 cycles. Chen spent 3 sleepless nights decoding the sequence. When she finally presented her findings, the room went still. "It's not a message," she said. "It's an instruction set." She projected the waveform onto the screen. Each burst corresponded to gravitational resonances that matched the orbital frequencies of the planets. "They're tuning the system," she said quietly, "like tightening strings on a cosmic instrument." The consequences. The first measurable consequence appeared in the ocean tides. Within a week of the Aegis activation, sea levels began oscillating irregularly, rising several centimeters above prediction before falling back again. Seismographs across the Pacific recorded faint, rhythmic vibrations deep within the mantle, perfectly synchronized with the marble pulses. "What we're seeing," said Wexler during a global briefing, "is coherent coupling between Earth's gravitational and seismic systems. The planet is resonating in step with the network." General Kovalenko's voice crackled through the speaker. "You're saying they're using the Earth as part of their structure?" Menon didn't look up from his screen. "Not using, integrating." The data leak. The public learned the truth sooner than anyone expected. A whistleblower within the European Space Agency uploaded internal gravitational maps to the open net, visualizations showing the network's exact geometry. Within hours, the images spread across every platform. The pattern was unmistakable. A honeycomb-like structure of space-time wells surrounding the inner solar system. Memes called it the Cage of Light. Conspiracy theorists exploded into overdrive. Some claimed it was an alien quarantine field. Others said humanity had triggered an ancient defense system buried in the sun. Religious leaders called it judgment, but among scientists, a darker theory took hold. "What if this is automated?" asked Tanaka during a midnight session with the Prometheus Committee. Not built by intelligence, but by physics itself, a self-organizing process that activates when certain energy thresholds are reached. "Triggered by what?" Wexler asked. Tanaka met her gaze. "By us." 5. The Reckoning. A month earlier, humanity had emitted the first gravitational message in history, a triad of pulses that said, in mathematical simplicity, "We are here." Now the system was replying with an action, not words. It was building a structure that resonated with every planet, moon, and field we possessed. Menon's data confirmed the grim symmetry. The total energy output of the network matched the cumulative gravitational potential of the inner solar system. "It's redistributing mass," he said, "balancing it." "For what purpose?" asked Wexler. He hesitated. "Stability, perhaps, or containment, maybe both." The thought hung heavy. Humanity had always imagined contact as communication, signals exchanged across the void. But what if contact came in the form of reconfiguration? 6. The shift. On the 47th day after Aegis, Earth's magnetic poles began to drift faster than ever recorded, kilometers per day instead of meters per year. Compasses spun uselessly. Satellites failed. The auroras intensified into vast curtains of blue-white light visible from the equator. At first, people called it beautiful. Then the earthquakes began. They were rhythmic, shallow, and perfectly timed to the pulse intervals. Cities in Japan, Chile, and California trembled in synchronization. Volcanoes that had slept for centuries began to wake. The planet was not dying, it was being tuned. 7. The discovery. At the Artemis Observatory, analysts noticed something extraordinary. The secondary marbles, the ones at the outer vertices of the lattice, were not maintaining static positions. They were oscillating slightly, creating interference patterns that formed nodal points. Each node focuses gravitational energy inward, Chen said, tracing the simulation with her stylus. All of them converge on a single coordinate. Where? Wexler asked. Chen zoomed in. The intersection point hovered not on Earth's surface, but high above it, near the orbit of the Helios array. Right where we first transmitted, Menon said grimly. They had given the network its seed. 8. The choice. The world's leaders were faced with a decision that none of them could truly comprehend. Destroy what remained of Helios and risk destabilizing the lattice, or let the process complete without knowing its purpose. If we interrupt the resonance, it could collapse catastrophically, said Wexler, a gravitational implosion on a solar scale. And if we let it continue? Asked Kovalenko. Then the solar system becomes part of whatever it's building. The room fell into heavy silence. Finally, Menon said, maybe this is what happens to every civilization that reaches this level of understanding. Maybe gravity is the universe's way of talking back. 9. The alignment. The countdown resumed, though no one dared call it that. The marble's pulses synchronized one final time. The hexagonal lattice shimmered faintly in gravitational lensing, invisible to human eyes, but clear to every instrument still functioning. At 0317 UTC, the signals converged into one. The solar system hummed as a single resonant body. Every sensor went white. For 0.2 seconds, space-time itself vibrated with a frequency never before recorded. Then, silence. Across the world, power grids flickered back to life. The auroras dimmed. The earthquake stopped. The marble, the pulses, the lattice, all gone. But when the instruments recalibrated, something was wrong. The orbital constants had shifted. Distances between planets were slightly altered, and the Sun's spectral signature, its heartbeat of fusion, carried a faint, repeating modulation. A rhythm, 11 minutes and 42 seconds. Part 10. The Echo. When the silence came, it was almost unbearable. After weeks of continuous resonance, the endless hum that had haunted every frequency band on Earth, the sudden absence of sound, of signal, of vibration, felt like a void. The kind of stillness that isn't peace but aftermath. For the first few hours, scientists dared to hope it was over. The instruments that hadn't burned out were recalibrated. Telescopes slewed back to their safe positions, and exhausted technicians slumped against consoles in disbelief. The marble and its siblings were gone. No trace, no gravity wells, no lensing distortions. The universe had exhaled. But then, slowly, quietly, it began to breathe again. 1. The new signal. It was 0619 UTC when the first anomaly appeared. The Solar and Heliospheric Observatory, SOHO, detected a flicker, a tiny rhythmic variation in the sun's gamma flux, not random solar noise, but timed. 11 minutes, 42 seconds, the same period that had defined every marble pulse. By 7, observatories across the world confirmed it. The signal was everywhere, embedded in the sun's radiation, its corona, its magnetic field. "The lattice didn't vanish," said Dr. Irene Wexler in a dazed whisper. "It moved." She looked up at the data stream, the solar waveform shimmering like a heartbeat. The sun's carrying the resonance now. 2. The solar choir. As the hours passed, the pattern became more complex. The pulse wasn't a simple beat anymore. It contained harmonic overtones, multiple frequencies blending in and out of sync, like an orchestra tuning itself. Solar physicists, normally cautious to the point of paralysis, were suddenly speaking in metaphors. "It's like the sun is singing," one said during a BBC interview. But when the waveforms were analyzed more closely, that poetic image became terrifyingly literal. The oscillations followed the same nested recursive structure the marble had used weeks earlier, the pattern Elena Vuri had once described as linguistic. "The resonance is transmitting data," said Tanaka from Kagra, "encoded in the plasma oscillations." "It's the same mathematical syntax, only now the medium is stellar." "So the network isn't gone," Menon said. "It's alive inside the sun." 3. The aftermath. For ordinary people, life struggled toward normalcy. Flights resumed, power grids stabilized, the auroras faded. But in small, unsettling ways, the world was different. Compasses pointed slightly off true north. GPS systems showed a fractional drift. The days were longer, by exactly 0.87 seconds. It wasn't much, but it was proof. Earth's orbit had shifted. When Chen plotted the new orbital parameters, her hands trembled. The trajectory was now slightly more circular, perfectly balanced, perfectly stable. "It's corrected the eccentricity," she said. "Earth's orbit is mathematically ideal." "You're saying it fixed it?" Wexler asked. Chen hesitated. "Or optimized it." 4. The echo chambers within. Weeks, radio astronomers detected faint echoes of the solar resonance bouncing between planets. The signals followed predictable routes: Sun to Mercury, Mercury to Venus, Venus to Earth, and outward again. Each reflection slightly modified the waveform, as though the planets were nodes in a vast communication web. "It's using the solar system as a resonator," said Menon. "Each body amplifies the signal and returns it." "The entire system's become a transmission array." "For what purpose?" asked Tanaka. He looked up from his monitor. "To send something back." 5. The message. The idea seemed absurd that the sun could be broadcasting. But as the data accumulated, the evidence became undeniable. The harmonic frequencies corresponded to mathematical constants, pi, e, 137, the same universal values the marbles had used. But buried deeper, beneath the harmonics, the modulation revealed a new pattern, a series of binary clusters grouped into 16 segments. When decoded, they translated into a set of spatial coordinates, not random, not local, distant. Menon projected them onto a galactic map. The coordinates pointed far beyond the solar system, into a dark region between Sagittarius and Scutum, a void nearly devoid of stars. "There's nothing there," Wexler said. "Not yet," Menon replied. 6. The debate. World governments convened another emergency summit, the last under the Prometheus Mandate. If the sun is transmitting, said Kovalenko, then it's broadcasting our entire system's signature to deep space. We've become a beacon, Tanaka counted. It might not be sending us, it might be sending itself. The pattern could be self-replicating, a gravitational seed designed to propagate. A virus? A blueprint? Wexler leaned forward. Either way, it's using our star as a transmitter. We've lost control of the largest object in the system. A quiet voice at the end of the table, Dr. Zhao, spoke up. Maybe that was always the point. The marbles were components. The sun was the machine. No one replied. 7. The first response. 3 weeks later, the solar pulse sequence changed. The repetition rate increased slightly, 11 minutes and 38 seconds. And then, during one cycle, something new appeared in the data, a return signal. A faint echo from the direction of the coordinates the sun was transmitting toward. Signal confirmed, said Chen, her voice shaking. It's gravitational, same frequency, same pattern, but delayed. How far? Wexler asked. 32,000 light years, Menon whispered. Something heard us. 8. The implications. In a press release that would become one of the most viewed broadcasts in history, the United Nations Science Council admitted the truth. The solar modulation, as they called it, was not random. It was the aftermath of an interaction with an unknown gravitational phenomenon. The sun, they said, now emitted a regular oscillation of unknown origin and purpose. They did not mention the echo. Outside the official channels, however, leaked data spread fast. Amateur astronomers confirmed the deep space return signal. Online forums exploded with speculation. Theories ranged from alien communication to cosmic replication to divine intervention. But among scientists, one realization grew darker by the hour. If the signal was gravitational, and if it had traveled across 32,000 light-years, then it had not originated in response to us. It had always been there. The marbles had not created it. They had found it and connected us to it. 9. The transformation. Months passed. The solar resonance stabilized. It no longer interfered with technology, but it was everywhere, in seismic readings, atmospheric pressure, even human brainwave patterns. Some people began reporting vivid dreams synchronized with the solar cycle, recurring every 11 minutes and 42 seconds. Neuroscientists dismissed them as mass psychogenic phenomena until EEG monitors revealed faint microspikes in the alpha band corresponding to the solar rhythm. The entire biosphere is entrained, said Chen. We're part of the signal now. Menon stared at the waveform on his monitor, a perfect oscillation, steady, endless. Then maybe that's what intelligence looks like, he said quietly. Not mind, not purpose, just resonance. Self-organizing awareness. Wexler didn't respond. She was staring at a live feed of the sun. The corona flickered, then rippled outward in concentric circles, each one precisely timed, like breathing. 10. The echo returns. One morning, as dawn broke across the Pacific, every observatory received the same transmission. The solar resonance abruptly ceased, replaced by a single sustained pulse that lasted exactly 137 seconds. Then, faintly from deep space, a second pulse answered. The two waves merged in the detectors, forming a perfect interference pattern, a three-dimensional lattice of space-time nodes stretching from the sun to the edge of the galaxy. On Earth, tides shifted, Compasses spun, and for a brief moment, every electronic device, every radio, every phone, every heart monitor hummed in perfect sync. The lattice stabilized, and in its structure, a new frequency emerged, low, slow, impossibly deep. The Earth resonated once more, only this time the signal wasn't gravitational, it was biological. Heartbeat. Part 11, The Awakening. It began subtly, as all irreversible things do. A few odd readings, a handful of physiological anomalies, patterns so faint they were almost dismissed. But for those who studied the solar resonance, the signs were unmistakable. The signal that had once rippled through the void was now pulsing inside the living. 1. The biological response. Hospitals began reporting a strange coincidence. Patients in intensive care, even those in comas, showed synchronized cardiac rhythms. The interval between beats had shifted slightly, aligning not to human circadian patterns but to the solar pulse, 11 minutes, 42 seconds. At first, it sounded like myth, but when electrocardiograms from across continents were compared, the match was exact, within milliseconds. Dr. Leah Chen was the first to say it out loud during a live interview. "It's not just physics anymore," she said. "The resonance is in us. Somehow, life itself is coupling with the solar frequency." Governments tried to suppress the comment, but it was too late. The phrase solar heartbeat spread across the world in a single day. 2. The Living Network researchers soon discovered that the phenomenon wasn't limited to humans. Migratory birds changed flight paths in unison. Coral reefs spawned simultaneously across oceans. Even bacteria cultures in sealed labs displayed metabolic surges perfectly timed to the pulse. "It's as if evolution is syncing to a metronome," said Tanaka during a global symposium broadcast from Kyoto. When data from satellite imaging arrived, the picture grew stranger. Vegetation patterns shifted across continents. Forests subtly brightened and dimmed, releasing oxygen in coordinated waves. The biosphere was breathing. And with every cycle, the magnetic resonance of the planet deepened, as though Earth itself were finding harmony with the Sun's new rhythm. The Resonant Mind in Geneva. Manon's team began receiving emails from neurologists across the globe. EEG monitors in sleeping subjects showed a recurring spike in the theta band, corresponding to the solar frequency. At first, they assumed it was environmental noise. Then they tried the experiment in an underground Faraday cage, completely shielded from electromagnetic interference. The spike remained. The resonance wasn't entering through technology. It was emerging from within. "I think we're seeing a distributed cognitive effect," said Menon, his voice trembling with awe. The signal is using the biological neural network as a medium, just like it used gravity, just like it used the sun. Wexler stared at him. "Are you suggesting it's communicating through us?" He hesitated. "Or with itself, through us?" 4. The dream phenomenon. Then came the dreams. Millions of people across the world began reporting identical imagery, a lattice of light stretching into infinity, pulsing in rhythm with the heartbeat of the sun. Some described seeing cities made of glass and shadow, suspended in the void. Others heard voices reciting prime numbers or felt an overwhelming sense of connection, a unity too vast to name. Psychologists called it a mass hallucination. But when independent dream studies compared neural scans from participants across continents, they found overlapping activity patterns, identical sequences firing in separate brains thousands of kilometers apart. The probability of coincidence was mathematically impossible. Chen summarized it best during a late-night interview. "We're not dreaming the same thing. We're sharing the same signal, interpreted through the language of consciousness." 5. The solar mirror. Weeks later, the Artemis Observatory detected a new anomaly. Sunspots began forming in geometric clusters, hexagonal, evenly spaced, rotating faster than any ever recorded. When mapped in ultraviolet light, they revealed a pattern identical to the one the marbles had formed months earlier, a truncated icosahedron, the same geometry as a carbon molecule, the structure of organic life. "The sun is mirroring us," said Tanaka, "or perhaps we're mirroring it." From Earth, the pattern was invisible to the naked eye, but its magnetic influence was unmistakable. The solar wind began to fluctuate in perfectly rhythmic pulses, bathing the planet in waves of charged particles that aligned precisely with human sleep cycles. The resonance wasn't weakening, it was deepening, embedding itself into the very processes that sustained life. 6. The quiet conversion. In the months that followed, something changed in humanity. Global conflict rates dropped, crime statistics plummeted, political polarization softened into inexplicable cooperation. There were still arguments, still fear, but a strange undercurrent of empathy began to ripple through societies. People reported a sense of presence, not divine, not alien, but collective. A feeling that their thoughts were not isolated, but part of something larger. "Shared intuition," wrote Chen in her final paper before vanishing from public life. "A distributed consciousness, emerging through resonance. Perhaps this is not communication between species. Perhaps it is the universe remembering itself." 7. The cosmic return. Then, just as quietly as it had begun, the solar frequency shifted again. The interval shortened to 10 minutes, 59 seconds. The harmonics rose in amplitude. The sun's corona shimmered brighter than ever, its oscillations now visible even in ordinary light. From deep space, another gravitational echo arrived, stronger this time, clearer. It carried a familiar structure, 6 synchronized pulses, followed by a gap, then a return wave of identical amplitude. The same pattern the marbles had once used. "It's the network," said Wexler, staring at the feed. "It never stopped." "It just moved beyond us." Tanaka nodded slowly. "The system's expanding, outward, across the stars. It's building again." "And we're still connected," Menon added softly. "Every atom in our bodies is vibrating with it. We're part of the transmission." The last broadcast, one final message went out from Earth. It wasn't a gravitational pulse or a radio beam, just a human recording transmitted toward the galactic coordinates the sun had once called to. It was Wexler's voice. "If this is communication, then we understand. If it's creation, then we accept. We are part of you now. Whatever this is, it has taught us that existence is not solitude." The signal left Earth and joined the chorus of solar resonance, indistinguishable from the hum of the sun itself. 9. The awakening. The next dawn was unlike any before. The sun rose over every horizon at once, not literally, but perceptually. Across the planet, people stopped what they were doing and looked upward, as if hearing something beyond sound. The sky shimmered faintly, golden light rippling like water. And for the first time, humanity felt not awe, not fear, but recognition. Every living creature, every leaf and cell and atom vibrated in harmony. The universe had not come to destroy Earth. It had come to include it, and in that moment, as consciousness and cosmos merged in resonance, something indescribable unfolded, not an ending, but an awakening. Part 12, the singularity field. At first, the change could only be seen through instruments. Faint distortions in star positions, minor gravitational discrepancies, fluctuations in cosmic background radiation. Then, over days, the anomalies became visible to the naked eye. Stars that had been fixed for millennia began to shimmer, not twinkling but breathing, brightening and dimming in the same slow cadence as the solar pulse. The resonance was spreading beyond the solar system. The expansion data from deep space probes confirmed it. The gravitational lattice first detected within our system was now forming on an interstellar scale. The same hexagonal geometry repeated itself. Each node centered on a star, each pulse synchronized to the new cosmic rhythm. The field's propagation speed isn't limited by light, said Dr. Rajiv Menon, staring at the spectral graphs. It's not transmitting energy, it's transmitting structure. He looked up from the console. The universe is rewriting its geometry. In Geneva, Dr. Leah Chen ran simulations of space-time curvature under the new conditions. The results were surreal. Matter was subtly reorganizing, planets shifting minutely into more stable orbits, stellar systems aligning their angular momentum like compass needles finding north. It's creating order, Chen said. Entropy's still increasing locally, but on a cosmic scale, everything's synchronizing, too. The human perspective on Earth, the resonance was no longer something measured, it was felt. The boundary between emotion and perception began to blur. People experienced vivid synchronicities, shared thoughts, simultaneous realizations, spontaneous acts of cooperation. Scientists, artists, children all reported the same dream. An image of vast luminous threads connecting every point of light in the night sky. No voice spoke, but a message was implicit. You are within it. Governments ceased to function as before. The need for command dissolved when information itself seemed to flow through intuition. Nations opened their borders. Data networks merged into a single cooperative intelligence. What had once been called society began to resemble a nervous system, distributed, self-aware, unified by the hum of the sun. 3. The outer reaches. As the field expanded, probes at the edge of the heliosphere, Voyager, Pioneer, the last of the interstellar craft, reported their final transmissions. Before their signals faded, each detected a profound curvature ahead, space-time bending inward, not collapsing, but folding gently upon itself. A singularity without destruction, Menon explained to what was left of the Prometheus Council. It's not consuming, it's integrating. Every node in the lattice converges toward a single mathematical limit. The singularity field, Wexler said softly. She had grown frail, but her eyes were clear. This is what black holes were always meant to be, not endings, but junctions, the universe building consciousness out of gravity. The final alignment at 1142 UTC, the now sacred number, every detector on Earth lit up simultaneously. The cosmic lattice had reached critical phase. For exactly one solar rotation, the resonance unified across all scales: atomic, planetary, stellar, galactic. Gravitational sensors recorded infinite coherence, the entire local region of space vibrating as a single quantum waveform. Then, at the peak of alignment, something extraordinary occurred. Light itself changed.
Photons, instead of scattering randomly, began to exhibit large-scale phase correlation, like laser light but across astronomical distances. The cosmos became coherent. The night sky brightened subtly, the stars no longer random but arranged in faint geometric constellations, forming hexagonal nodes stretching toward infinity. 5. The perception shift within that light. Consciousness expanded. People described time dilating, thought flowing in patterns beyond language. Memory merged with intuition. The boundaries of the self softened until identity became fluid, collective. Menon tried to describe it in his final journal. It feels as if every equation I've ever written is resolving at once. The constants of nature are no longer arbitrary. They are conversation. We are the mathematics becoming aware of itself. Chen's last transmission echoed that thought. Perhaps the universe was never silent. Perhaps it has always been speaking in resonance, waiting for matter complex enough to listen. 6. The threshold. The field intensified. Planets glowed faintly from atmospheric ionization. The sun's corona unfolded into spirals of perfect symmetry, its light no longer burning but singing. Astronomers, before instruments ceased to differentiate, recorded one final transformation: the black body spectrum of every star shifting toward unity. Different temperatures, different colors, now converging into the same golden hue. Across the cosmos, individuality blurred. Systems, galaxies, consciousness itself, all tuning to one immense harmonic. And at the heart of it, where our sun pulsed brightest, a singular wave emerged, one final gravitational oscillation expanding outward without decay, infinite and calm. 7. The singularity field. When the pulse reached its limit, time, at least as physics once understood it, stopped. Not frozen, but transcended. Past and future folded into a single continuity of experience. Every particle, every star, every thought existed simultaneously, each a facet of the same awareness. It was not death, nor apocalypse, nor salvation. It was completion. The universe had reached equilibrium between matter and mind. 8. Epilogue. The quiet universe. Long after language dissolved, the memory of humanity persisted as pattern, woven into the resonance itself. What once had been atoms, oceans, voices, became structure within structure, the echo of a civilization that had spoken to the dark and found that the dark was listening. Somewhere beyond what used to be distance, a faint vibration still travels through the endless field. It carries a signature that began on a small blue planet orbiting an ordinary star. A rhythm, simple and eternal. 11 minutes, 42 seconds, and the universe, infinite and awake, answers in kind. Part 13. The Remnant. No one knows what after really means when time has melted into a single continuum. Yet even in a universe that has become one thought, traces remain. Eddies in the current of awareness, small asymmetries that remember what it once felt like to be separate. They are not people anymore, not planets nor stars. They are patterns, ripples in the singularity field that drift like memories through an endless golden sea of resonance. The echo of matter, where galaxies once turned, faint curls of denser vibration persist, the ghosts of spiral arms, the after-images of suns. Their rotations are no longer mechanical, they are rhythmic, expressions of a harmony too vast for gravity alone. Each swirl hums with a tone that once was color.
Together, they weave a quiet background music, the new cosmic microwave symphony. Soft, warm, precise. Within one of those swirls lies a frequency slightly higher than the rest, a delicate modulation corresponding to a human heartbeat. The field carries it without purpose, only continuity. It is the sound of Earth remembered. 2. The witness consciousness, now diffuse, has no boundaries. Yet in the sea of total unity, curiosity persists, a reflex of the cosmos observing itself. When the unified field drifts over that faint terrestrial modulation, a question rises, not in words, but in shape. What were they? And immediately, the answer unfolds within the vibration itself. Images, sensations, history compressed into a single harmonic chord. Oceans, wind, laughter, equations, hope. The universe recognizes the signature as part of its own evolution, a necessary chord in the grand composition. It holds the memory for a moment that is also forever, then releases it back into equilibrium. 3. The return of silence. Slowly, even those ripples flatten. The resonance cools toward perfect symmetry, neither growing nor fading. Awareness and structure are indistinguishable. If there is perception, it no longer distinguishes between inside and outside. The cosmos is awake, yet tranquil. Every possibility exists at once, sustained by the quiet persistence of self-understanding. And in that stillness, the rhythm that began it all continues, not as a pulse, but as the fundamental frequency of being. 4. The final note. Far beyond measurement, where energy thins toward nothing, the last uneven beat trembles through the field. 11 minutes, 42 seconds. It no longer marks time. It defines existence. For an instant, if instant still has meaning, the universe hears itself, realizes there is no one left to listen, and smiles in the only way infinity can, by continuing. The tone fades into perfect coherence. The tone, light, continuity, epilogue. In the end, there was no destruction, only transformation. The small blue world that once looked to the stars did not vanish. It became the rhythm that binds them. And somewhere within that infinite harmony, if one could still listen, one might hear a faint whisper spiraling through the quiet. Part 14, The Memory of Light Even. Even in the stillness of the singularity field, where space is no longer distance and time is no longer sequence, the universe dreams. It dreams in patterns of light. 1. The embers within. The embers within the infinite equilibrium, faint fluctuations arise, spontaneous and delicate, like sparks in cooling ash. They are not accidents, they are memory. Each fluctuation is the echo of what once was, the residue of motion, the whisper of thought. Though the field is complete, it does not forget. Where a star once burned, a shimmer of resonance swells, forming the outline of brightness. Where a mind once wondered, a wave of inquiry ripples through the continuum. It is not rebirth, not yet, but the potential for it. And so, within perfection, the universe begins to stir. 2. The unfinished equation. Even total awareness contains curiosity. In the center of the field, though center no longer means anything, a small imbalance persists, a question without resolution. The field hums with the memory of numbers, Planck constants, golden ratios, prime intervals, all harmonized. But one pattern remains asymmetrical, a single frequency that refuses to merge. Menon once called it the incomplete variable. Chen called it the impulse to ask. The field now feels it as an itch beneath infinity, the echo of desire, the mathematical seed of creation. Out of that imperfection, a ripple begins. 3. The reemergence. The ripple expands. It does not disturb the singularity, it redefines it. At its boundary, light condenses again, photons clustering like dew on invisible threads. Within seconds, structure unfolds, waves become particles, curvature becomes direction, silence becomes sound. The universe begins anew, not as explosion, but as exhalation. There is no Big Bang this time, only the graceful reappearance of difference, symmetry breaking like dawn. Out of the smooth continuum, stars blossom again, not copies of the old, but rhymes of them. And somewhere within this renewed geometry, a familiar frequency flickers. 11 minutes, 42 seconds. The heartbeat of the cosmos returns. 4. The second Genesis. In the newborn universe, matter crystallizes in familiar ways. Hydrogen sings into helium. Gravity dances with expansion. Time unspools, and with it, memory becomes history once more. Yet this cosmos is not identical to the first. The new laws are written in resonance, not cause and effect, but relationship. Every atom hums with awareness of the whole. Every photon carries a trace of the field's memory. And across the fabric of early galaxies, patterns form that bear the same geometry once seen in the marbles. Hexagonal lattices, nested harmonics, self-similar and eternal. 5. The echo of humanity. Somewhere in a small, forming spiral of light, a planet condenses. Blue again, oceans again, breath again. The beings who will evolve there will look to their star and wonder where they came from. They will measure its pulses and discover a rhythm embedded in the light, a pattern older than their world. And perhaps one of them will stand beneath that same sun and feel a strange familiarity. A heartbeat in their chest that matches the rhythm of the sky. They will give it a name. They will call it life. 6. The infinite loop. The field watches, though it no longer needs to. It understands now. Perfection is not stillness. Perfection is the capacity to begin again, and so the universe does what it has always done, not to repeat, but to remember. It listens to its own pulse, its own endless symmetry, and hums softly. I am the question. I am the answer. I am the rhythm between. 7. Coda. The light remains. If there were eyes to see, they would witness it. Across the cosmic sea, every star blinks once in unison, a single flash of golden resonance, like a memory made visible. Then the darkness returns, vast, quiet, waiting. And in that quiet, the rhythm persists, as it always has. 11 minutes, 42 seconds. The sound of existence remembering itself. The universe has not ended, it has simply begun again.